Okay, so here we are on the boat again. What I'm doing now is I'm changing the spark plugs that were fitted by the boat engineer some time ago. These are the ones that are getting very carbonated. They're not quite the right spec. There's a little video I'll shoot to in a minute and just explain what I've found. So I'm going to swap over the plugs. I'm going to change the fuel regulator to a different fuel regulator just to see if I can get the pressure on the high pressure fuel rail to around the 50-55 mark, and then we'll see if these new spark plugs make a difference. Okay, so spark plugs. If you look up Volvo Penta spark plugs, you'll see an AC Delco 41101, and then the number is 12568387. Again, 12568387. If you look up that spark plug, you'll find it's identical to these spark plugs, 12681664, and this is how you buy them. So this spark plug came out of this box, which came out of these. So I don't know why, but the spark plug that you get in this box has this number on it. And this is the Volvo approved spark plug. I'll put the full technical specs up so that you can see. This is the one that came out of the boat. It's an AC Delco. If you look at the spec on it, in terms of thread size, it's almost identical, apart from it's a very cold running plug, and the number is completely different, 41983. And you can see 12578277. This is a platinum plug, this is an iridium plug. So we're going to fit these in the boat and we're going to see if it makes any difference. The biggest difference between the spec on these two is the fact that this one runs a lot hotter. Volvo specify this particular spark plug. This spark plug has a heat ratio rating of 4. The one that's been fitted on my boat, although the spec of the spark plug is very, very similar, albeit it's platinum, not iridium, the heat range on this is 14. Significant difference. This plug runs a lot colder than this plug. I'm not sure if that's making the difference, but when I do look at the research, it says if you're running spark plugs which are too cold, then this is the effect you get. Carbonated, black, because this plug is not running hot enough to clean itself. So we're going to swap these spark plugs over and see what happens. So I've changed the spark plugs to the new spark plugs, the right spec. I've put a different fuel regulator in, so I'm just going to see what the fuel pressure is once I ignite, turn on the ignition and energise the fuel. We'll see, and if all is well, we'll try and start to see what happens. just seen what a difference it makes changing those spark plugs. The boat started first time, ran really sweet, very smooth, and the biggest thing was that heat range. So I've done a little bit more investigation with that, and basically when you're running hot spark plugs, they're for a basically been designed for a petrol naturally aspirated engine, and you want a spark plug where it's going to run quite hot at the tip, and what that does is it easily ignites the petrol, and it also, by running hot at the right temperature that has been designed for that particular engine, it's actually cleaning itself. So a telltale sign, which I didn't realise until I've done this investigation, is that if you're getting black carbonated plugs and they're getting wet, it doesn't necessarily mean you're giving it too much fuel. If it's a cold running spark plug, it means the spark plug is not running hot enough to ignite that petrol properly, and it's not running hot enough to clean itself, which is why it gets all black and carbonated. So it's been a very interesting exercise. It's amazing. I never knew about heat ranges on spark plugs until I pulled up the specs for the spark plug that have been fitted to my boat, and pulled up the spec for the spark plugs recommended by Volvo. And the other thing I've found on the research is that each engine manufacturer will have tuned the performance of their engines and found out which spark plugs work better for their engines within that heat range. So the heat range is probably something that drops off the scale that not many people talk about with spark plugs, but it's incredibly important, as I've just witnessed. So great news. So I'm just going to take you to a little bit of video I found explaining heat range and what it does to spark plugs. Quite interesting, just a little clip.
The heat range actually has nothing to do with how hot a plug fires. It is really a measurement of how much heat is either left at or removed from the tip of the spark plug. Both a hot spark plug and a cool spark plug will require the same sparking voltage. This slide illustrates the difference between a hot spark plug and a cool spark plug. As you can see, there are different insulator designs for hot and cold plugs. The hot plug has less insulator mass near the thread shell, while the cool plugs have more insulator mass near the thread shell. A hot spark plug will have a slower transfer rate of heat away from the tip of the plug, while a cooler plug will transfer heat from the tip more rapidly. The plug on the left is a hot spark plug. The plug on the right is a cold spark plug. You can easily see the insulator design difference. At the pre-production or engineering stages of an engine, much time is spent researching what spark plug design and heat range will be most suitable for an engine. The spark plug tip needs to maintain a temperature between 500 and 800 degrees Celsius. Using the correct heat range for your application is vital to getting the performance and reliability you expect. If too hot of a heat range is selected, and the spark plug tip temperature rises above 800 degrees, the engine may experience pre-ignition, leading to costly spark plug and possible engine damage. If too cool of a heat range is selected, and the spark plug tip temperature does not rise above 500 degrees Celsius, the spark plugs may quickly begin to foul, causing misfire and eventually leading to engine stalling or a no-start condition.
So having now successfully got my engine running, and running very, very well, having changed the spark plugs, I'm now going to set about draining the fuel out of the fuel tank of the boat. Now that I'm running, I need to get that old fuel out there. I don't want to be sucking old fuel out the fuel tank and putting all through all my injectors and all my fuel system when I've cleaned it all out and the engine is running sweet. So that's what we're going to be doing next, draining the fuel out the fuel tank of the boat.